So the first part of a quality rep is the problem statement. This is where we summarize the mathematical problem to be solved. So as you can see, this background information is pretty wordy. So we can summarize this by just identifying the 5 W's. So our problem statement is to calculate the distance in meters that Cadet Dobbs travels from 0 to 50 seconds in order to determine the length of diagonal walk. Now that we have a problem statement, we can move on to assumptions. We must identify and justify the assumptions necessary to make our mathematical model valid. For our mathematical model, we need to make 2 assumptions. We must first assume that Cadet Dobbs runs in a straight path with no deviations in elevation or direction. This is necessary to assume because in order to make a valid calculation of position based on a velocity function, we must be able to make a calculation in 1 dimension. This is a reasonable assumption to make because Cadet Dobbs is running across diagonal walk, which is a straight level surface. There's a second major assumption that we need to make in order for our mathematical model to be valid. We must also assume that Cadet Dobbs does not stop running forward and does not run in the opposite direction. This is necessary to assume as Cadet Dobbs must be able to produce a positive velocity for our function to be valid and must have a constant direction. This is reasonable because Cadet Dobbs is running out of time and cannot afford to turn back now. The next step of the quality rep is formulation. This is where we define our given constant parameters, our independent and dependent variables to solve for, and our primary equations with their necessary descriptions and units of measure. So the constants are what we've already been given. So we've been given a function for velocity on the first interval, which is from 0 to 18 seconds, a function for velocity on the second interval, which is 18 to 26 seconds, and a function for velocity on our third and final interval, which is from 26 to 50 seconds. Our velocities are in meters per second, and our times are in seconds. Next, we have our variables. Our dependent variables are what we are solving for. So d1 is the distance traveled during our first interval, d2 is the distance traveled during our second interval, and d3 is the distance traveled during the third interval. Capital D is the total distance that we traveled. Our independent variables we've already discussed. They're v, which is Cadet Dobbs' velocity, and t, which is time in seconds. Our dependent variables are all measured in meters, and our independent variables are measured in meters per second and seconds. Next, we have the equations and theorems that we'll be using. The first equation, which will be labeled as equation 1 in our methodology, is anyone, Euler, just kidding, is the fundamental theorem of calculus. We will be using that in order to determine the integral of the velocity function to get a value for distance. Our next equation, which will be labeled as equation 2 in our methodology, is the substitution rule for definite integrals. We'll need to use substitution in order to determine the integral of the third velocity interval. Our third equation is the fifth property of the integral, which basically is the fact that if an interval is continuous along a to c and b to c, then you're able to add these functions together to get an interval from a to b of f of x. We'll be using that in order to determine the total distance, diagonal walk, after calculating the 3 individual distances. We need to visualize our problem. Graphed Cadet Dobbs' velocity over time. In this graph, we can see that on the first interval, Cadet Dobbs is at a decelerating pace until he reaches 2.5 meters per second, and on the second interval, at a constant pace. And once he reaches 26 seconds, he accelerates until 50 seconds at an increasing acceleration. So with this graph, we can see that the total distance of diagonal walk is the area under the curve for interval 1, 2, and 3. The next element of the quality rep is the methodology. This is where we describe the problem-solving process. Alright, so for methodology, the first thing we're going to do is find d1 by using the fundamental theorem of calculus part 2 to integrate v1 from to time 1. The second thing we're going to do is find d2 by using the fundamental theorem of calculus part 2 to integrate d2 from time 1 to time 2. The third thing we're going to do is find d3 by using the substitution rule for definite integrals to determine first the integral of v3, and then we're going to use the fundamental theorem of calculus part 2 to integrate v3 from time 2 to time 3. After that, in accordance with the fifth property of the integral, we're going to add d1, d2, and d3 to get capital D, which is the total length in meters of diagonal walk. With that, we will have solved our problem. The quality rep is results. This is where we calculate the distance of diagonal walk. For results, for the first step, we integrated the first velocity from 0 to 18 seconds, and got that the distance was 81 meters. For step 2, we used the fundamental theorem of calculus to integrate the second velocity from 18 to 26 seconds and got 20 meters. For step 3, we used the substitution rule to find the integral of the third velocity from 26 to 50 seconds. And using the substitution rule, we got that u is equal to numbers inside of the square root. Found the derivative of u to be the derivative of those numbers times the derivative of t times t. And then we were able to use that to substitute the derivative of u for time function and the derivative of t. We integrated and found the distance to be 126.6 meters. And for step 4, we used the fifth property of the integral in order to add these three distances to get a total distance. So the total distance of diagonal walk is 81 plus 20 plus 126.6, which comes out to be 227.6 meters. And that is our result. Still here? Movie's over. Sign out to TAPS. Go.